everyone. This is our junior certificate mathematics lesson. Today's topic is linear equations. My name is Rawanekar. I'm with a learner here called Esmond Muzipe. Join us as we discuss this topic further. Let us have a look at today's objectives. The objectives of this lesson say solving linear equations of the form ax plus b, where a, b, and c are constants of whole numbers. That is, a, b, and c are whole numbers. They should be whole numbers. And then we'll go on and solve problems involving application of linear equations in real life situation. Now, I've got an example here on the board with me. Let us have a look at it and then discuss it. The example is 2x plus 9 equals to 11. The unknown here is x, and we can see that it's a linear equation. So we are going to solve for the unknown. In this case, the unknown is x. Now, when solving linear equations, we start by collecting the like terms. So we have a 9 here and then 11 here. So 9 and 11 are like terms. So we will move this 9 to this side of the equal sign. Let us remember that the 9 here is positive. Now, as we take it to this side of the equal sign, it becomes negative. So this will be 2x is equals to 11 minus 9. Because the 9 is positive, now we are taking it to this side. It becomes minus 9. And then this will be 2x is equals to 11 minus 9. This is 2. So 2x is equals to 2. And then we will divide both sides by 2. This is the 2 that we are dividing by. Divide both sides by 2. 2 here once, 2 here once, and then 2 here once. It's 1, and then 2 here once. So what we have here now is x is equals to 1. So the value of x is 1. This is our x. So I've solved the linear equation that you required me to solve. Let me find out from you if at all you do want us to solve another equation of this kind.
Thank you, sir, for that example you just given. But can you go further and elaborate on the equations which involve unknown variables from either side of the equal sign? Can you give an example?
Thank you. You want me to show you an example where the variables are on two sides of the equal sign. That is where the variables are on both sides of the equal sign. Let us have an example of that kind and then try to solve it. Equations with the unknown on both sides of the equal sign. So this is the example that will answer your question. 8p plus 3 equals to 5p plus 12. There are two unknowns on the two sides of the equal sign. Now, just like the first example, what we'll do here is we will collect the like terms. So this 5p, we can move the 5p this side, and then the 3 this side. 5p and 8p and 5p are like terms, and then 3 and 12 also other like terms. So this will be 8p minus 5p is equals to 12 minus 3. We have just collected the like terms here. 3 and 12 are like terms. 8p and 5p are also another like terms. Now 8p minus 5p is 3p. This will be equals to 12 minus 3 is 9. This is 9. So we have 3p equals to 9. Now remember, we are solving for the variable p. Now, just like in the first example, we are going to divide both sides by p so that the variable p remains on one side of the equal sign, not a p, but this is supposed to be a 3. We are dividing both sides by 3. So 3 here once, 3 here once, and then 3 here once, 3 here, it's a 3. So the p is equals to, rather the p is equals to 3. So our p is 3. Our P is 3. Now, I believe this has answered your question, Esmond, because you wanted me to give you an example where the unknown variable appears on the two sides of the equal sign. Now, we can always check from our equation here where we substitute the 3 for P to check if at all the right hand side will be equal to the left hand side. Let us check. 8 multiplied by 3 plus 3 is equals to 5 multiplied by 3 plus 12. Now the rule says multiply first. 8 times 3 is 24 plus 3 equals to 5 times 3 is 15 plus 12. This is supposed to be plus. And then 24 plus 3 is 27. It's equals to 15 plus 12. This gives us 27. So the right hand side is equals to the left hand side. So the P is equals to 3 is correct. I believe this has answered your question. Now, let us go for a short break. When we come back, we will continue with our discussion. Welcome back from short break. We are still solving linear equations. Now, let me hear from Esmond what else he wants us to cover as we discuss this topic.
You have helped me, sir. But can the equations with brackets be solved?
Thank you. You want me to give an example of an equation which involves brackets. And such equation should be a linear one. Now, I've got such an example on the board. Let us discuss it and solve for the variable. The example is 7, open the brackets, q minus 8, close the brackets, equals to 63. Now, we are going to start by removing the brackets in this equation. We can see that there are some brackets here. So we'll start by removing these brackets as we'll solve this equation. Also, let us remember that the number 7 here, it's multiplying everything inside these brackets here. So this simply means 7 times q, it's 7q. 7 times minus 8, it's minus 56. You can always use your calculator if you are not sure. 7q minus 56, it's equals to 63. 7q minus 56 equals to 63. Now, this is a linear equation. It's just similar to the first example that we started with. After opening this bracket, it becomes similar to the first one that we started with. Now, here we are solving for the variable q. We are therefore going to collect the like terms. We've got 56 here, and then there is the 63 here. So 56 and 63, these are like terms. So this simply means we'll take this 56 to this side of the equal sign, so that we end up with 7q, it's equals to 63 plus 56. Let us remember that it's 7q equals to 63 plus 56. Let us remember that the 56 here is negative. Now, as we take this side of the equal sign, it becomes positive. That's why it's plus 56. And then now this will be 7q. This is 7. 7q, it's equals to 6 plus 3 is 9. This is 119. So 7q is equals to, this is a q, it's not a 9. It's a q. So 7q is equals to 119. Now remember, we are solving for the variable q. We therefore now divide both sides by 7 because we are solving for the variable q. So we'll divide both sides by 7. Let's divide by 7 here, and then divide this side also by 7. This is a 7. 7 into 7 is 1. 7 into 7 here is 1. So this side, it's a q only. We are remaining with a q. Q is equals to, and then 7 here once. 7 into 11, it's 1. Remainder 4. And then 7 into 49, It's a 4 here now. 7 into 49, it's a 7. So Q is equals to 17. This is the value of Q. Let us look at another example to elaborate more on what we have just done. Let us look at the example 5. Open the brackets. 2x minus 1, close the brackets, is equals to 4. Open the brackets. 2 plus 9x, and then close the brackets. We can see that in this example also there are brackets involved on the either side of the equal sign. So we'll start by opening up the brackets. 5 times 2x, remember the 5 is multiplying everything inside this bracket. So 5 times 2x, this is 10x. 5 times minus 1 is minus 5. It's equals to 4 times 2, it's 8. And then 4 times 9x, it's plus 36x. Right. It appears a little bit simpler now for you. Now, let us collect the like terms, because every time as we solve these linear equations, we must make it a principle that we start by collecting the like terms. So it's a 10x here and then 36x here. When I look at this, this is 10, this is 36. So I'll take the 10x this side and then the 8 this other side. Now, this is, I'm taking 10 this side, minus 5, minus 8, because the 8 here is positive, so as I take it this side becomes negative. Minus 5 minus 8, it's equals to 10x plus 36. The 10 is positive, so I'm taking this side becomes negative. This will be 36, which is positive, minus 10x, because as we take it this side of the equal sign becomes negative. And then minus 5 minus 8, this is minus 13. It's equals to 36 minus 10x. This is 26x. So what we are simply saying here is 26x is equals to negative 13. Now, remember we are solving for x. So we are going to divide both sides by 26. Divide here by 26. 26 here once, 26 here once. So x will be equals to, now let us make sure that we simplify this. We can't leave it as minus 13 over 26. 13 into 13 to negative 13, it's a negative 1, divided by 13 into 26, it's a 2. So the value of x is negative half. The value of x is negative half. Now, I believe this has answered your question. We have solved an example which involves brackets on the two sides. As we look at here, you can see that there were two brackets involved on the either side of the equal sign. So the principle is, let us just remove the brackets and from there collect the like terms and then solve. So in this example, we got our x as negative half. So let us remember that every time when we solve equations involving brackets, we start by removing the brackets. Welcome back from the short break. Remember, we are still solving linear equations. Now, let me hear again from the learner here with me, Esmond, what else he wants us to cover.
Sometimes when I'm studying, I can experience difficulty in forming equations. Can you give me a live situation and solve it?
Thank you. You want me to cover an example which involves a real life situation. Now, let us have a look at the example on the board, which I believe will answer your question. From that example, we will then solve it. The example says a scroll in the form of a rectangle, and this is a rectangle, and a playing field shown below have the same perimeter. All measurements are given in meters. Now, it says that a scroll in the shape of this triangle and this playing field, which is in the form of a rectangular shape, have got the same perimeter. First, let us understand what perimeter is all about. Perimeter simply means the distance around the shape. So in this question simply says the distance around this shape is equal to the distance around this rectangular playing field. So it means we are going to form equations and then equate the two. Then after equating the two, we will solve for the variable x. So let us solve those, let us rather form those equations. It says find the value of x, find the perimeter of this. So the first question says we are to find the value of x. For A, 25x plus 25x plus, this is supposed to be plus 25x plus 60, it's equals to, and then what about the rectangular playing field? It's 20x, and then if this is 20x, this side also is 20x. This one is 50, meaning this side also is 50 because this side is equals to this. So that will be 20x plus 50 plus 50. So that is equals to 50 plus, it's 50 plus 50 plus, what is the other dimension? We have to check if at all we are correct. The other dimension is 20x. So it's plus 20x plus another 20x plus another 20x. So this 50 plus 50 plus 20x plus 20x, this gives us the perimeter of the rectangular playing field. And then the 25x plus 25x plus 60, this gives us the perimeter of the triangular crawl. Now 25x plus 25x is 50x. 50x plus 60, it's equals to 50 plus 50, this is 100. And then at 20x plus 20x, it's plus 40x. It's plus 40x. Right. Now we've got an equation which appears a little bit simpler. 50x plus 60x equals to 100 plus 40x. Now, just like we have been doing, we are going to collect the like terms. We've got the 60 here and then the 100. 60 and 100, these are like terms. And then we've got 50 and 40. 50 and 40 are also like terms. Now, let us continue with our work here. This becomes 50x minus 40x. Remember, the 40 is positive, so as we take it to this side of the equal sign, it becomes negative. So 50x minus 40x, it's equals to 100. 60, take it this side of the equal sign, it becomes 100 minus 60. And then 50x minus 40x is 10x. 10x, it's equals to 100 minus 60, it's 40. And then now the equation is 10x equals to 40. Divide both sides by 10 to solve for the variable x. You divide by 10. Now 10 here once, 10 here once. So this side is just an x. It's just an x. So our x will be equals to 10 here once, 10 into 40, it's 4. So our x is 4. Our x is 4. This simply means in this triangular playing field and rectangular playing field, the value of x is 4. We have solved that equation. Now, the question says, the first question says find the value of x. So we have solved the first part. Our x is 4. That is the first part. The value of x is 4. Now, let us go on and answer part B. Part B says find the perimeter of the rectangular playing field. So we are to find the distance around this shape. This is the rectangular field. So we are to find this distance around it. And we can see this is 20x, 50. Now we know the value of x. So what will be the perimeter? The perimeter should be of the rectangular playing field is 20 times the value of x. Our x is 4, and then we multiply this by 2. Why are we multiplying by 2? It's because there are two identical sides. And then plus 50 plus 50. Remember, perimeter is the distance around the shape. Let us check. We should be sure. Yes, it's 50 and 50. So it's 20x times 2 plus 50 plus 50. Now, let us work it out. 20 times 4, it's 80 multiplied by 2 plus 50 times, rather 50 plus 50 is 100. So it's 80 times 2 plus 100. 80 times 2, 2 times 0 is 0, 2 times 8 is 16. So it's 160 plus 100. 160 plus 100. This gives us, there should be equal signs here. This gives us 260. 160 plus 100 gives us 260. So this simply says the perimeter of the rectangular playing field, that is this one, the perimeter of this shape is 260, as we have seen it. I think what I've done here, I've answered your question where we were forming equations in real life situation and then solving that equation. This is how equations in real life situations are solved. We have now come to the end of our lesson. But remember, we were solving linear equations, which involves whole numbers. And I believe we have achieved our objectives. Now, this is all that I have for you, and I believe you have enjoyed this lesson. Please keep revising linear equations till we meet again in the next lesson. Goodbye.